the complexity, the storage, and then the retrieval, they're all completely different from the earlier examples. And you, if you very carefully pay attention to some of these applications very carefully, you will see that each of these unstructured applications are themselves example is a very distinct application from all of these 10 unstructured applications. These are the biometric databases. And what is this these about? You all have at some point or the other have interacted with these things. Maybe you all have Aadhaar cards. And Aadhaar is all about storing and retrieving the biometrics of the citizens of this country. They store the fingerprints, they store the facial face database, and the purpose essentially is that they will be this application will be the one that is responsible for verifying who this individual is, which means that you can no more say that is this student with roll number is the registered student of this institute. It's not based on the roll number, it is not based on any such kind of attributes, but it is physical attributes. It is the fingerprint. Is this fingerprint is in your database? Which means that these kind of queries inevitably invoke to predict to classify whether this fingerprint exists in your database, it matches with your database or not. That match itself is all about learning algorithms. So these databases are much more complex. Their scale, volume, and then the queries, they all are completely different from all the previous 10 examples. So having discussed about exhaustively 10 diverse applications in the structured databases and 10 diverse applications in the unstructured databases, we have seen some kind of queries that are associated with each of these databases. We'll see that what is it a database is all about and what it will offer to us. And at a very high level, and in this particular course, I wanted to emphasize that we will be dealing only with the structured databases. That is the first and foremost thing, which means that we will be only looking at tables, collection of tables, and then receiving the queries from these collection of tables, constructing the replies, and then showing it to the end user. And no more than this one. And unstructured databases, their organization, other things is out of this. So what is database management systems? It's all about a general purpose software system. It's a very general purpose software system. By that, what we mean is that this DBMS software can be installed for a university database. At the same time, it can be same software can be installed for a banking application or an insurance application or a land records application. All the applications that we have seen so far with respect to the structured databases, the underlying software is the database management system software. And what is database management system software? Is a collection of programs that enables users to create and maintain tables. You can, for a minute, you can exchange the word database with tables. So you have a collection of tables, and collection of tables is the database.
Hello, sir.
Database is a collection of tables. Tables are collection of columns and rows, right? And what you are playing with is that operations on such kind of
Hello, sir.
storage structures.
Good morning, sir.
And DBMS facilitates
Hello, sir.
in defining
Hello, sir.
what is a table, how to construct a table, how to manipulate a table, how to share database among various users and applications. This is where this database management systems depart from conventional any software application. And one example is that if you take university system database like AAMS, at any point in time, there will be several users who will be interacting with this database. Now, when we say several users, these users have roles.
Excuse me, sir. Can
Yes.
you please start the recording for this lecture?
Yes, please go ahead.
Can you please start the
Someone is
recording for
saying
this
something.
lecture? Yes, sir.
Yeah, please go ahead. Complete your question.
I just wanted to say that can you please record this lecture? Some people are asking that in the chat box.
Yes. Please go ahead. And one more thing is that once again I wanted to tell all of you is that as I am on full screen mode, I may not be able to view your chat messages. If you wanted to interrupt, please feel free to unmute your mic, ask a question. Once again, you can record this lecture, not an issue.
Hello, sir.
Yes, please go ahead. Yes, please go ahead.
Hello,
Am
sir.
I audible?
Sir,
Yes, yes.
sir, I'm saying you are the only person who has permission to record this lecture. So, yeah. Sir, Yes, sir, you are record. Sir, I'm asking you to please record the lecture, sir. Hello.
Okay, these permissions are changed. That's what you are saying.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I'll try to see how to record this session. How to record it. So let me see what are all the queries students are posting. These are all yesterday queries. Today queries. So kindly check the chat. Okay, but I cannot check the chat. So my request is that you please have to unmute. Sir, please record the lecture. I'll do that one. Internet connection is poor. Your voice is breaking. I'll be bit louder, but technical issues I cannot be able to resolve. Your voice becomes unclear sometimes. I'll be louder. Please record the lectures and update them. Yes, but you have to help me how should I record? Start recording. Perfect. I am recording the lecture. After the meeting, you can find the recording of the conversation on Microsoft Teams. Got it. So students, I have started recording the lecture. So, so I will now proceed with the lecture discussions particularly. The database management system, once again, I just wanted to recollect, is that is a collection of programs that enables to create and maintain databases. And once again, I wanted to tell you that you can, for this particular instance, you can replace database with tables. So database management system is a collection of programs that enables users to create and maintain tables, right? And it's a general purpose software, which means that you can use the same collection of programs for storing data pertaining to university system, or you can use the same database system to store the data of a banking application or a hospital application or land records and so on and so forth, which means it will not differentiate which application you are engaging with. It is immaterial. It's a generic purpose software system. And what all it offers to the user is that it offers to the user of defining what is a database for you. How do you construct this database? How can you manipulate? And then share this database among various users and applications. This is much more very important. As I told you that at any given instance of time, there will be several users engaging with this database system, And all these users need not be having the same role. In the university system, and the example of AAMS software, assume that two students are logged in into this application, and Dean of Academic Affairs logging into the system, and database maintainers are also logging into the system. Each of these users' tasks are completely should be able to understand that several roles are there, and I must cater to these roles the data in different formats. Same data in the same table, but I present in a different format. Example is that the student, when he logs in, he requests that you give me the grade sheet. So the system must show him grade sheet, his or her grade sheet alone. Should show how many courses that are being offered and what all courses the grades are yet to be submitted. It is not that it should not populate the information about the student specific information. Well, if the dean wishes so, then it should be able to, but otherwise it should show something yes, or tries to look at. At the same time, if the database administrator logs in, it should give much more flexibility in terms of the content that is being uh, stored in the database system, which means that sharing the database not only involves sharing the data as is, but sharing the data pertaining to the views. Student view is different, dean's view is different, database administrator's view is with the database, their view must be different. That is the much more important requirement from the perspective of the database. Similarly, manipulating the database is based on these roles. You cannot dissociate manipulation of the data with respect to the roles. Constructing and defining are much uh, sparse events that actually occurs with respect to the database, and they are all with respect to the administrators. But still, they are also engaging in with the roles of the users. And when I say users, you have to keep in mind always that it is not a physical user. User need not be the one that is physically present with respect to the database. And one example is that when you have tried to book a ticket, you try to select a internally it will generate some request to external database application of the bank. So airline system is contacting the banking system. Now from the banking system's perspective, so this program is interacting with the program, and hence it should essentially do not differentiate between a program or a software or a physical user. So the
Sir, your
more
voice
number
is
of
breaking up here. Your voice is breaking up here.
yes, I understood. I wanted to, okay, I will speak louder. Thank you so much for the input, but some of these things I wanted to see how to resolve this one. Maybe from tomorrow, hopefully, I will be able to bring out clear, um, uninterrupted internet facility. Hopefully, I do not know exactly. But for today, you please bear with me. So these users need not be the humans always. These users can be programs. That's what I wanted to emphasize on that point. So all of these operations must be
Sir, you are muted, I think.
No, I have not muted.
Okay, sir.
Can anyone hear me?
Yes, sir, now you are audible.
Yes, yes, yes. So I am speaking much louder. I'll see how to manage with the voice. So now when I'm saying about data structures, one example that I wanted to draw your attention is that if you look at the course code, it has fixed number of characters. Say over here 5 to 6. 6 I mean when a minor course is offered, let us say CES 441M. That M character is also added, so it will contain 6 characters for the course code. But if you say course name, the course name can be varying. You cannot assume that all courses will have identical
Sir, you are not audible.
Hello everyone, can you hear me?
Yes, sir, now we can hear.
Sir, until now you have
Okay,
been
okay.
muted, sir.
So until now I am been muted.
Yes, sir. We cannot hear you. Just now we are listening your voice.
Yes, so for the last 1 minute or
Okay.
so, you were inaudible to us.
This problem is maybe
Because
see I am not doing any muting explicitly, but maybe because of the internet issues I am facing this issue. Right, I am not changing any of these settings. But please bear with me for this class. From next class I will try to resolve by shifting physically to another location where I have better internet connectivity. Is that fine?
Sir, but we are unable to understand anything. Like your
Yes,
voice
yes,
breaks
I understand. I
between the
understand.
lecture.
I'll yes, yes. I'll if you want me, I'll repeat these contents.
Sir, sir, again, we are not able to hear you now.
Hello.
Yes, sir, now you are audible.
This is very strange. Okay. I have to make it. Maybe I have to take this little bit rigorously and then see where how to fix this issue of audio. Okay. But please bear with me. Please bear with me for today's class. I will next class onwards. You will have better audio related issues, sir. Can you see the slides at least? Hello.
Yes, sir.
Yes,
Perfect. Perfect. So I wanted to draw to your attention that when we are actually trying to say about data structures, the point that I wanted to make is that you have to make a decision of how many characters that you wanted to store in the table of this column course name. If you say that I need to store for every row of this particular table against the course name fixed number of characters versus variable number of characters. That is a decision that you have to inform to the database. So such kind of things are the data structures and data types are the inbuilt data types. Inbuilt data types, what are the inbuilt data types? Is that the types that are allowed by the database system. Over here there will be many data types that are present associated with the storage structure integer. And whereas integer is your integer in your C programming language, big int is very specific to the database system, right? So now the identical constraints will come when you operate with these kind of storage structures. One example is that if you give a tiny integer storage structure, and if the variable, if the row is taking 127 value, and you wanted to increment this row from 127 to 128, it will have a overflow error. Why? Because the maximum value that can be stored in the tiny int is 127. Now you actually wanted to increment 1 to 127. What will happen? Over. So this is one way of understanding the storage structures and then their limits. If you exhaust, it will not give you, it will not kind of cease to run the program, but it will give you warning saying that storage structure errors actually have occurred, right? Not only about these particular not only particular to the implementation specific constraints will be associated with the storage structures, but constraints also be placed in the database, on the databases. Example is that if you say that course numbers, so I'll give you one example, is that class slot is a column in this table. This class slots must be adhered to the timetable slot system, A to F and then A1 to F1. It cannot take any more values. Even though you say that it is two, it can take 2 characters. You cannot say class slot is AA, AB, right? So now what actually happens over here is that inherently the constraints comes into play on the data that you are storing. One, you have to specify the data types. Another is that you have to specify the data structures, on top of which you have to place constraints on these data types and data structures that you have associated with. In addition to this, there will be descriptive information that is stored by the database. Very high level, and you do not need to be very much worried about of whether we have understood about the defining the databases. These are at a very high level that you have to see. If you wanted to specify a database or specify a table, you have to create a table. You have to, and for each column you have to specify the data types. For each column you have to specify the data structures. For each column you have to specify the constraints. Once you have done that one, you can construct and manipulate the data that is that is stored. So construction is nothing but the process of storing the data on some storage medium. When we say that we wanted to store the data, the question that we have to ask is that where are we storing it? Is it on the main memory? If it is on the main memory, it is a volatile database. It cannot actually live forever. For a minute you take it in this form, right? But there are examples of in-memory databases. We are not even talking about that one. We are talking about a program that essentially executes and then completes its execution. After the completion, you do not have any data that is left because everything is in the main memory. But when we are essentially talking about databases, the data must be stored on a medium, and this medium must be a hard disk or a storage medium that so you have to specify this construction. Once you have done that one, you have to do the manipulation, which means that you have to manipulate tables, which means that you have to say that you perform one operation on two tables, or you perform another operation on one table, and so on and so forth. The other thing that you can actually do is that updating the database or updating the tables, generating the reports from the data. And the example that we have seen in the previous class with respect to our academic section data is list of the courses offered by the department-wise list of courses, the list of open electives, and so on and so forth. They're all the reports that are generated. Now, the important point is that the generated reports are not the exact form in which data is stored. If you can understand this point, you understand the meaning of report generation, which means that if you, for a minute, if you say that I store all the 6,000 students' information, their roll number, their name, and then their department in a table, and then if the query comes that you show the list of the students pertaining to ECE department, you will filter out all other rows in this particular table except the rows that actually have ECE in the student's department name, against the student's department name. It's a report, but what inherently stored is a list of all the students, roll number, name, and then their department. This is what is physically stored, but the reports are not stored. Right? This is the important point. And manipulation is all about querying, updating. Querying is a very generic. And sharing the data is all about generating views that for this particular set of students, or let's say this particular department, I wanted to generate this view, even though your tables does not change. Right? That is the main point that we wanted to memorize. An example that we and we see how this can be defined. As I told you that everything is in form of tables. So we wanted to specify student information about the student, information about the courses, information about the sections, grades, reports, prerequisites. Each of them assumes tables. Student is the name of the table. It contains 4 columns, and each of the column stores certain data and data type. Right? So over here, the name stores the name of the student number, roll number, the class, and then which department he is studying in. And here identical rows will all be identical, and there can be several rows. So over here, course related information you actually are storing in courses table. So is the case with the sections, and so is the case with the grade reports and then prerequisites. Yes, is a collection of 5 files or 5 tables. Here 2, 3, 4, and 5. Database is a collection of 5 tables, each of which stores data of same type. When I say over here type, what it means is that student table stores information about only students. It will not be able to store information about courses. That is what I mean to say. And every table or file can store identical formats of the specified definitions of the tables. So defining each of these table involves specifying the different data elements, the name, the student number, class, and major, You also have to say what is the data type of the name. It's a character string. Student number, it must be an integer. Over here, you can actually go back and then say is it a tiny integer, is it a small integer? Is up to you. But you have to specify what is the type of the data that you are actually storing for the roll number or the student number, and so on and so forth, right? But some things will be very, very specific. It is not, see, even though you are saying that student number must be of the form integer, can it take this value, negative numbers? It cannot. So you have to specify that, well, student roll number is an integer, but it cannot take, even though the range is minimum value to the maximum value, the range of the number that you can the roll number, student roll number. It must be starting with the first two digits must represent the year, and so on and so forth. There are many rules that you will be having, and it must adhere to that one. So these rules must be kind of written, saying that, well, even though it's a roll number, it must have these kind of constraints. You have to specify it. Otherwise, what will happen? It can so happen that a student number, roll number can assume negative values, which is incorrect in form of the database, and it will essentially affect the loss of confidence on the users that your data has errors in your, you have errors in your data, and people immediately lose confidence on the data that is being populated. The way in which you wanted to construct the data in terms of tables. I just wanted to kind of go forward. And manipulating means that you cannot say that give me the salary of the faculty given all these 5 tables. You cannot say that one, because such data is not stored for at this moment, so you cannot answer any of such kind of queries. So the queries must involve only these 5 tables. And what is it that we wanted to ask is that retrieve the transcript of Smith. So it must be able to compute internally based on the grades from the Smith's roll number, and then it should essentially populate which all the courses that Smith has done, and what is should populate a grade report for Smith. So it involves a lot of computation, and this computation must be specified. It's the name of the students who took database course in fall 2008, and their grades in this section. So these are the kind of queries that you can post to these 5 tables. And manipulating also involves updating that one. Change the class of the Smith. So over here you have written stored the class of student. Student Smith class essentially is 1. Now you wanted to change it to 2 or 3. So it is all involves updating the database. So it's not only about updating, you can actually create new records, you can create a new section, you can enter grades and so on and so forth. You can think of various operations that you can perform on this table. These are only representative examples that we have listed over here. Now the main point that we wanted to talk about with respect to the database is that the data that is stored is huge in terms of the volume. One example is that if you talk about railway reservation systems database, per day it stores of the order of terabytes or petabytes of data of reservations of the passengers. Now any query, 1 terabyte or 10 terabytes of data, you will run out of the physical storage structure devices that can store this data. That is one thing. Second, you cannot store all this data in one single file. If you ask this question that, see, only reservations if you take, if the reservations per day takes terabytes of data, now these 10 terabytes cannot be stored in a single file. So it must be spread across files and across physical storage structures as well. One example that I wanted to give you is that, let us say in our university system, 6,000 students' data is stored in the database, and assume that our main memory can hold data equivalent to 100 students at any given time. And if you are asked this question that list the roll numbers and the name of the student, course code and then course title in the semester, particular semester, and sort by roll number. What it means is that first of all, you cannot load the data onto the main memory, because your main memory can hold data equivalent to 100 students, but you have 6,000 students in your data and your physical storage structure. So what is it that you have to do is that, so now every database does this one, or let's say various databases, any database for that matter, does this one, that it will store, no, it will do the computations on the disks. It is not no more on the main memory. Why? Because the data that is stored is much more than the size of the main memory, many a times. And that means that even a simple algorithm like sorting must be done over iterations. It must do through 60 iterations to perform this sorting. So you take first of the 6,000 students, you take first 100, then next 100, then next 100, perform the sorting on the main memory, write back onto the files, take next chunk of 100 students, and you repeat these issues, repeat this procedure. The point that I wanted to make is that you please note that the database always does these computations using disks only and using file system only. Whenever possible, it can perform the operations on main memory if the data can fit in the main memory. But if the data cannot fit into the main memory, it has but no options to perform these operations using intermediate files. So that is what is the main challenge of any simple computation that we are essentially asking on the database. So all these queries many a times involves invoking intermediate files and then doing the computation and then presenting it to you, the results. So now, okay, let me just take a minute and then ask if there are any questions from the student side. Nitin, Karan, Alakveer Mandal, no questions? Perfect. So let me, I'm reading these names because those are the ones that are appearing on my screen. No bias. System is all about. See, the database system architecture is of this form. I mean, this complete architecture is of this form. That the database system somewhere its heart is over here in this box. But it can engage with the users in multiple formats. It can engage users with web forms as your AMS or as your airlines reservation system, Or in terms of applications, standalone applications, computer will pop up a dialog box and then you modify, let's say, some of these fields. So it also is all about database and it's a application specific. It is not a web-based forms, right? It is still a form, but it's a form internal to the specific terminal that you are invoking. And many a time, so over here it actually has some query select star from employees as whatever. So it actually has multiple formats in which input can be taken from the users. And all the inputs translate to SQL commands. So it will beat web forms, beat applications, beat SQL interfaces. They all will be converted into a SQL query. And even this one also, your AMS login and password will internally convert into a specific query over here as this one. Commands of this nature. Once this is converted into SQL command, it will be given to the database. Is that it will immediately parse this SQL query. It will actually parse this SQL query to see whether this is syntactically correct or not. So it will actually generate a parse tree internally. Once this parse tree, there is no errors with respect to the SQL command, it will actually go through the optimizer. What is the meaning of an optimizer? See, example, if it is the parse tree, it will actually transform, optimizer will automatically transform into this parse tree. So it knows that which operation is very much faster. Once these operations are optimizer does its business, it goes to the operator evaluator. Evaluator will say, first you evaluate this operation on the movie table, then you perform the operation on the stars in table. Then you do this operation. Then you do this operation. Then executor role will come. Executor, what it will do? Gives you the plan of what all operations that you can perform on the tables. First you do this operation, next you do this operation, next you do this operation. All this report will be forwarded to the executor. Executor will actually execute these operations on the databases, on the tables. And what it will involve? It will immediately understand, well, there are, these are very long tables. If it is a very big table, so if you will, then it will say that whether there are indexing structures are associated with it. When I say indexing structures, you might have done some form of indexing in the form of, let's say, binary search trees, right? You have learned from your database data structures class course several data structures to store the data and retrieve the data. All such kind of structures are over here. So it will, let's say, ask this question that are there indexing structures available? If yes, make use of it. If the data is available in the buffers, you make use of it. Well, if something is not available, you go to the disk. I'll go to the disk and then I will fetch it. That's exactly what it will be doing. And once it is all done, it will construct this query, execute it, and then the reply will be given to, from the executor, the reply will goes to the web forms, the reply will go to the applications, the reply will go to the web interfaces or the storage interfaces. So over here, once this query is fired, so the reply will be constructed and then given, reply will be given to you. recovery manager is that transaction manager, what it does is that the evaluator is it is in the middle of doing something. I am trying to understand to make a reservation for a particular customer. There are simultaneously several customers are, let's say, coming in to book a seat onto the same flight and then same seat on same day. What it does is that it will logically makes them in line in a queue. And then whoever comes first in interacting with the database, it tries to write that particular customer's name against that particular seat. And a very high level. I am not going into the complete details, but that is what actually it does. And lock manager, what it is responsible for is that as long as this customer is doing modifications to the database onto the disk, nobody else can make changes to this disk. When there is a power failure that happens, when a software crashes, when your application itself crashes, when your web forms crashes, web servers crashes, when your applications crashes, when your interfaces crashes, when there is the entire database management system crashes, or when power failures occurs. Failures can be at multiple levels, and you are in the middle of doing particular transactions. Now what happens is that you have to recover. You cannot say that, well, I do not know what actually has happened. So database must know exactly at which stage are you in, and then can I undo this operation or completely complete that operation. That's exactly what is the thing. So all these things is part of the database architecture. Any questions? If there are no questions, then we will conclude the class today. We'll meet tomorrow, and I'm sure that I'll make sure that I'll relocate to a new place where there will not be any issue with respect to the audio. Thank you. I'm